So today we're introducing some Pythagorean identities. This is part of our chapter on trig identities. And so we're going to start with, here is our unit circle, right? As a review, we've got our radius of 1, and we have this kind of right triangle where we can find the x distance, remember, is the cosine of our angle, and the y distance here is the sine of our angle to find the coordinates of that point. But notice that we have a right triangle. So what's a relationship we know about the three sides in a right triangle that's always true? Okay, here's a hint. Right, of course we're thinking that a squared plus b squared equals c squared. The Pythagorean Theorem, right? Hence the name Pythagorean Identities today. So instead of writing a, b, and c, let's write in kind of the values we have here. So our two legs would be x and y. So we could say x squared plus y squared equals our hypotenuse 1 squared. Now, if we turn this back into what we know about the unit circle, what does x represent? What does y represent? Okay. Remember, x represents the cosine of our angle, and sine represents the y of our angle. So another way that we can write this is cosine squared of theta. And when we write the trig function squared, we put the square before the argument, which would be theta here. But cosine squared plus the y coordinate, sine squared, has to equal 1 squared, which is just 1. Okay, this is a very important Pythagorean identity to memorize. Sine squared, cosine squared plus sine squared equals 1. Okay, very important. We will use that a bunch. And this is one of 3 Pythagorean identities. And as long as you remember this one in a pinch, you can derive the others. And to do that, which we're going to do in the next slide here, we'll divide this identity, sine squared plus cosine squared. I know I wrote it backwards here. It doesn't really matter which order. We're going to divide each side by cosine squared and sine squared. Okay. So sine squared plus cosine squared equals 1. Again, the order of these two is not important, but if you add them together, the squares of them, it equals 1. We're going to divide everything on both sides by cosine squared and simplify. So let's take the Pythagorean identity we have, sine squared plus cosine squared equals 1. And we're going to divide everything on both sides by cosine squared of theta. So you get divided by cosine squared, you get divided by cosine squared, and you get divided by cosine squared. Well, you might remember sine squared divided by cosine squared, or here's a review, tangent is equal to sine divided by cosine. So if I have sine squared over cosine squared, that's equal to tangent squared. This turns into tangent squared of theta. Well, cosine squared divided by itself turns into 1, so we get plus 1. And 1 over cosine, now remember that secant of an angle is the reciprocal of cosine, right? So if we have 1 over cosine squared, that equals secant squared. So this last fraction, the reciprocal of cosine, is secant. That becomes secant squared of theta. This is our second Pythagorean identity. Tangent squared plus 1 equals secant squared. Okay, let's find our last and third identity by dividing, again, the same original Pythagorean identity, but instead of dividing everything by cosine squared, we're going to divide it all by sine squared. So we're going to take our original identity, divide by sine squared of theta. So once we divide everything by sine squared, we're going to see what we can turn some of this into. Of course, sine squared divided by itself, that's 1. Now, cosine over sine, that's not exactly tangent, but it is the reciprocal of tangent, excuse me, which is cotangent. Cotangent is cosine over sine. It's the reciprocal. So if I have cosine squared over sine squared, that's equal to cotangent squared. And 1 over sine, what's the reciprocal of sine? Secant. Sorry, cosecant. Apologies. And because it's squared, this is equal to cosecant squared, right? 1 over sine of theta equals cosecant of theta. Right, so if we square all those, we get cosecant squared. This is our third and final Pythagorean identity. Okay, so here are our 3 Pythagorean identities we just derived. Now we're going to write down some things that we already knew before just to have them handy, which also includes that tangent is defined as sine over cosine. Cotangent is the reciprocal there, cosine over sine. And that cosecant and sine are reciprocals of each other. Right? Cosecant is 1 over sine, or sine is 1 over cosecant, etc. So secant is 1 over cosine, etc. So we're going to use these to try to substitute in an equivalent expression for each of these given expressions. So the first one I notice, anytime I see sine or cosine and we have something squared and there's a 1 floating around. Sine or cosine is squared and there's a 1. I'm thinking immediately this Pythagorean identity. So if I were to start with that Pythagorean identity, sine squared of theta plus cosine squared of theta equals 1, how can I make it look like this? 1 minus cosine? Well, here's 1. Let's move cosine to the other side. And check it out. Now I have sine squared of theta equals 1 minus cosine squared of theta. So with a little manipulation, what does 1 minus cosine squared of theta equal to? Sine squared of theta. There's my equivalent expression I could substitute in. Okay, here's number 2. See if you can figure out number 2. Go ahead and pause the video. Okay, and you should have come up with that's equal to cosine squared of theta. Again, taking our original Pythagorean identity. So we see a sine squared and a 1. Hey, how can I make it look like that? Subtract sine squared over. So 1 minus sine squared of theta equals cosine squared of theta. So our answer there would be the cosine squared of theta. What about cosine squared? Or sorry, sine squared plus cosine squared. Hopefully you recognize that's sine squared plus cosine squared. What could I substitute in for that? 1. That's equal to 1. If you saw that expression and you needed to try to simplify some trig expression, you see sine squared plus cosine squared of the same angle, you can replace it with 1. Okay, well, what about tangent? Now, there's probably a few different things we could write. Right here, I see tangent is 1 over cotangent. You could write that. By the way, a lot of these earlier ones, we could also have done maybe different answers, but these are the more obvious ones. You could say that's 1 over cotangent. That's true. Or you could say it represents, remember its definition, is sine over cosine. And eventually when we have to do kind of proofs with trig functions, it's good to know that we do both of these. But more importantly, breaking things down into their sine and cosine portions make things a lot easier. So either one of these would be correct. I would probably go with this one. It'll be more useful when we do proofs. Okay, so here's a few to maybe try out. Try 5 and 6. See if you can figure out what to replace those with. Actually, go ahead and try all 6 of these. All right, so these are some of the possible answers I came up with for some of these. Cotangent, you could write as 1 over tangent, or by its definition, cosine over sine. Tangent squared from our identity would equal secant squared minus 1. You'd have to move that 1 over. So using the Pythagorean identity, we can get that. Or from its definition of tangent, sine over cosine squared, since it was tangent squared. Or its reciprocal, 1 over cotangent squared. So lots of different ways that you could write this. Again, when you do proofs, typically going to sine and cosine is a great way to go. And typically you don't want to add in extra terms like a minus 1 if possible. but sometimes it's necessary. So again, this is probably the best way to write cotangent for number 5, but all of these are valid options for this. Secant squared, now via our Pythagorean identity, is tangent squared plus 1, or, and again when you're doing proofs, going to sine or cosine is probably going to help out more, 1 over cosine squared. But this is fine because we're also practicing Pythagorean identities. Cosecant squared is equal to 1 plus cotangent squared from the identity, or if you change it to sine or cosine, 1 over sine squared. Both of these would be good answers for today. Tangent squared plus 1, hopefully we recognize that straight from up here. That is secant squared of theta. 1 over sine squared is cosecant squared. Now maybe there's some other stuff you could replace here, but this is probably the best option to continue if I'm trying to replace that. So you could probably write a few more answers for some of these, but these are probably the best two, I would say, to continue forward with. Okay, that's it for these. We're going to definitely do a lot more expressions in class. We'll even do the beginning of some kind of trig identity proofs, but these 3 identities are really important. The reciprocals are important to know, and your definition of tangent and cotangent are important. Okay, make sure you're at the live session. It will be important to practice these so that you feel confident going into your quiz.